All right, so first some notation. As before, we've got our world times our m is our projective equation. And notice we've got two versions here. And again, what we're saying here is that uv1 is projectively similar to wu, wv, and w. And in fact, in order to get back uv1, I could take wu divided by w in order to get that. And that's actually what's written on the bottom. All I've shown is that ui, that's for point I have to take the product, that's the first row, divided by what becomes the third row. Same thing for vi. So the point here is that I get a pair of equations for every point. For every point I here, I have an equation that goes from xyz to ui and xyz to vi. So what we're going to do is we're going to have to solve for this M matrix using a whole bunch of points. Just continuing, I just slid those equations up, and now I've just carried through, just expanded it through. And one thing you'll notice is that every term has an M in it. And for those of you who know anything about linear algebra, that should start to worry you just a little bit, because typically when I want to solve a linear set of equations, I hope that there's some term that doesn't have a variable in it. And we'll see that in just a sec. So I have this pair of equations for each point. All right, writing it again like that. So now the question is how best to solve this. All right, I'm going to write this in a little bit different way. So here I have all my variables, and here for just one point I have my coefficients. So notice my coefficients involve capital X's and Y's and Z's. Those are the values out in the world, along with the V's and the U's, which are the points in the image. Now stretch way back into your memory from linear algebra, and you might remember that usually you were solving equations of ax equals b, and you could have more equations than unknowns, and you'd do a least squares solution. But there was a particular kind of set of equations where the right-hand side was referred to as a homogeneous set of equations when they were all equal to 0. And that's why this is a homogeneous set of equations, not just homogeneous coordinates. These things are all sort of related, and when you get really, really old, you'll figure that out. But for now, you can just remember that these are homogeneous equations. So the question is, how do we solve that? Because obviously there's a trivial solution. What's the trivial solution? Well, if a times x equals 0, and I'm looking for an x, well, no matter what a is, x equals 0 would be a solution. So I could just say all the m's are equal to 0. And that would not be a very satisfying solution. So the question is, what's the best way to solve this?